Hey everyone, welcome. So if you're gunning for that AWS Solutions Architect certification, you know that phrase, designing for failure, isn't just a buzzword, it is everything. Today, we're going to master a really critical tool in your high availability toolkit, Amazon Route 53 Health Checks.
So here's our game plan. First, we'll cover the why these things are the guardians of your app's availability. Then we're going to peek under the hood to see how they actually work, look at the different types you'll need to know, and then see them in a real-world failover setup. And of course, we'll wrap up with some crucial exam tips that you definitely won't want to miss. All right, let's kick things off with the one single problem that every single cloud architect is fundamentally hired to prevent.
What's that one thing that can just completely destroy your most brilliant design, frustrate all your users, and hit the company right in the wallet?
Yep, it's downtime. Simple as that. When your application goes dark, you're not just losing a little bit of data. You're losing money, you're losing user trust, and you're losing your reputation. Just about every resilient architecture out there is built with one big goal: fighting downtime.
And that brings us right to our solution. I want you to think of Route 53 Health Checks as your system's automated 24/7 doctor on-call. They don't just tell you there's a problem, they are the actual trigger that tells AWS, hey, route users away from this mess, often before a single person even notices something's wrong.
So how do these checks really work? Let's peel back the layers and get into the mechanics of what's happening behind the scenes.
You know, it's a pretty simple but incredibly powerful four-step loop. You've got these health checkers all over the world that are constantly just pinging your endpoint, asking over and over again, hey, you okay? You still there? If they hear silence or, get the wrong answer, for a certain number of tries in a row, they make the call. They declare the endpoint unhealthy. And that's when the magic really begins.
Now here's where you, the architect, get to pull all the levers. You get to control the protocol, how often it checks, and how many failures it takes to sound the alarm. But the real pro tip here, the one you got to remember, is string matching. Just imagine this. Your server is up, but it's only serving a 500 internal server error page. A simply check would pass, but your app is totally broken for your users. With string matching, you can tell Route 53, hey, I need you to look for the word success on the page. If that word isn't there, the check fails. It's the difference between checking if the lights are on versus checking if anyone's actually home. Super powerful stuff.
Now this isn't some one-size-fits-all deal, it's more like a toolbox. And for the exam, you need to know exactly which tool to grab for which job. So let's look at the three main types of health checks you'll see. First up, the endpoint health check. This is your workhorse, your everyday tool. It does exactly what it sounds like. You give it a public IP address or a domain name, and Route 53 just checks if it's reachable from the internet. This is your go-to for public web servers, your APIs, really any resource that's facing the internet.
Next, we've got the calculated health check. And this is where things get really smart, especially when you have a whole fleet of servers. See, instead of failing over your entire application just because one server hiccuped, you can create a health check of health checks. You could set a rule like, look, only declare the whole fleet unhealthy if, say, at least 40% of my servers are failing their own checks. This gives you this awesome layer of resilience and stops you from freaking out over false alarms.
Okay, but what about the stuff that isn't on the public internet? Like a database tucked away in a private subnet? This is a classic exam question, and the CloudWatch Alarm Health Check is your answer. You can create a CloudWatch alarm for pretty much any internal metric, CPU, memory, whatever. Then you just tell Route 53 to monitor the alarm itself. If that alarm goes off, the health check fails. It's a really clever way to keep an eye on all your private infrastructure.
Theory is great and all, but let's actually see how these health checks become the absolute linchpin in a real disaster recovery plan. This is where we stop just knowing about the service and start really thinking like an architect.
So on the exam, you're going to run into two main failover strategies. There's active-passive, which is a great, cost-effective way to go. A primary region does all the work, and a standby region is just, well, standing by. Then there's active-active. It's more expensive and way more complex, but it gives you that seamless, zero-downtime failover because all your regions are serving traffic all the time. Let's walk through a classic active-passive setup to see these health checks in action.
All right, so here's our setup on a normal, sunny day. All of our user traffic is happily flowing to the primary region. Our secondary region, it's ready to go, but it's scaled down to 0 to save us money. And in the background, a Route 53 health check is just relentlessly pinging that primary endpoint, getting a steady, consistent, all-clear signal. Everything's good.
And then it happens. Disaster. The application in our primary region just goes down. The Route 53 health checker sends out its pings, but all it gets back is silence. And once it hits that failure threshold we configured, it makes the call. The primary endpoint is officially unhealthy.
This right here is the magic moment. That unhealthy status is the trigger. The Route 53 failover routing policy, which has been just sitting there waiting for this exact signal, springs into action. Without a single human touching anything, it stops sending DNS requests to that failed IP and immediately starts sending all new traffic to the standby endpoint in our secondary region. And just like that, automated recovery is happening.
Okay, we have totally covered the core concepts. Now, let's lock in two very specific gotchas that pop up all the time on the Solutions Architect exam. You are going to want to commit these to memory.
So here's a classic exam scenario for you. You've got a critical database server, it's on an EC2 instance, and it's in a private subnet, no public IP. So how in the world can Route 53, with its health checkers out on the public internet, possibly know if that instance is healthy?
And this brings us right back to our third type of health check. See, you don't monitor the instance directly. Instead, you create a CloudWatch alarm based on an internal metric, maybe something like the status check failed metric. Then, and here's the genius part, you create a Route 53 health check that doesn't monitor the instance at all. It monitors the alarm. If the alarm goes off, Route 53 marks the health check as failed. It is such an elegant and secure pattern, and you absolutely positively have to know it for the exam.
Okay, our second exam tip is all about security. These Route 53 health checks, they're coming from the public internet, which means you have to let them through your security groups. So how do you do that without just, opening up your instance to the entire world?
Here it is, the best practice and the answer you're looking for on the exam. Do not try to manage a long list of IP addresses that AWS could change at any time. Don't do it. Instead, AWS gives us a managed prefix list specifically for Route 53 health checkers. You just add this one list as an inbound rule in your security group, and AWS handles keeping it up to date. It's secure, it's simple, and it's the right answer.
So, let's just bring this all home. The main thing to take away is this. Route 53 health checks are not just a passive monitoring tool. They are the active nervous system for a self-healing architecture. They enable the decisive, automated action that is DNS failover.
And that really is the core job of an architect. It's not just about knowing the tools, it's about using them to build systems that just don't die. So as you keep studying for the exam, always ask yourself this question. Now that you can reliably detect failure, how are you going to design to survive it?